talk about the transaction logs, WAL files in Postgres. My name is Devrim Gunduz. I work for EDB. This is my Twitter account and this is my Instagram account, just in case. I love taking pictures, so I use both of them. I'm using Redis since 1996 and using Postgres since 1998, so it's been like 25 years since starting using Postgres. Currently major contributor to the project. If you have ever used the RPMs for Fedora, Red Hat, CentOS, or not CentOS, Rocky Linux, I'm the guy who built RPMs. I'll just also maintain the small parts of the website. I also do some Fedora packaging, EPAL packaging. I live in London, and I have the Postgres tattoo, just in case. This is the actual tattoo. So please, I ask the community not to change the logo, because if you change the logo every year, I have a big problem. And nowadays, I'm also doing some DJing, which is my other full-time job. When I started DJing, I thought it would be just an easy process. No. I feel like the year 1998 when I started using Postgres, because I was spending like 40 hours per day to learn about Postgres. So this is how it goes. So if you are on Twitter, please tweet, take some pictures, make sure that you tweet so that you can spread the word to your friends, colleagues, or followers. And you can also please follow PGUS. PGUS is a Twitter account of Postgres US Association. If you are not over there, just go and be a member if you're around here. They are the guys who are responsible for organizing these talks and etc. And we have the main account, Postgres. So we will talk about WAL. The first version of this talk was in 2018. Of course, since then, lots of things changed in Postgres. And may I ask you to come a bit further forward if you want, if you can, and if you want. The reason is that there are some slides, there are some screenshots that may not be visible from there, but it's all up to you. So I'm going to talk about WAL, what does it include, what are the use cases, overhead, everything. As per the title, almost everything you would like to know about WAL. So if you have any questions, please raise your hand. Feel free to interrupt me, no problem. Ask me a question. If I know the answer, I can answer. If I don't know the answer, I'll make sure that you get the answer as soon as possible. First of all, in all of my seminars, trainings, this is the first thing I say about WAL. Please do not delete WAL files. As I told you, I started my career as a system administrator, so most of the sysadmin guys tend to remove the log files when something goes wrong, right? Because we need a disk space, and the first thing you delete are the log files. And then WAL files. The second thing that I ask them, do not delete. If this is not enough, please do not delete, please. Okay? So actually, this whole presentation is going to talk about why you shouldn't do this. So basically, we are talking about logging of transactions in Postgres. I'm going to show you the overhead, or what it means, what it does, everything in this presentation. It used to be Xlog. So if you are using 9.3 and below, or if you use Postgres in 9.3 and below, you probably remember the PG underscore Xlog directory. So the reason that we changed PG Xlog to PG WAL is because people used to delete the WAL files. Log files and WAL files. That was the reason that we changed. If you're taking a picture, you can take a picture. Okay. It's 16 megabyte by default. In most of the installations, it's 16 megabyte. It's a packager. I can tell you that in Windows, in RPMs, in Debian world, or the default compile versions, everything is 16 megabytes by default. It can be configured with, well, 6 size or in all the supported Postgres versions, which is Postgres 11 and above, initDB also has a WAL sake size parameter. Okay, so let's say if you say 64, it's going to give you it's going to increase the single WAL file to 64 megabytes. Okay, so there has been some debate in the past whether increasing the default would be beneficial or not. But I mean, none of the tests has proved anything. So like we are just leaving the 60 megabyte by default. There are some good reasons for this. I'm going to mention it probably later on. If you are familiar with operating systems, like most, let's say, file systems, I'm sure you know the concept called journaling. So when there's a journaling file system, like NTFS on Windows, or ext3, ext4, XFS, Btrfs on Linux, they all have a journal area. This is actually used to recover the system fast enough when there's a power failure. Okay, this is used to prevent to like start the system as soon as possible after a crash. Okay, the same idea is available in Postgres as well. So you can think of WAL files as a journal for Postgres. The same idea. When something goes wrong, something crashes, you use it to replay the data. I'll get there. We'll get there. And of course, there is a lot of benefit of using having WAL. One of them is data files are not changed on in each transaction. So if you have like frequent updates to data files, if you have been to the previous talk of Chelsea in the next room, she mentioned about like heavily updated tables. So like if you are updating the table like frequent enough, they are not written to the data files immediately. They are just written to the WAL files. Of course, there is a lot of overhead of doing this, but the benefit is we are getting rid of bloat from that point of view. Bloat is something else. Bloat is still there. It will be there, but we will maintain less bloat on the tables by having WAL files. Again, we will get there. So there's a performance benefit as well. So I never, I mean, my friends tell me to remove this line from my slides because, you know, everyone is on cloud, right? Personally, I don't like cloud. Okay? I have very good reasons because I'm old enough. I'm 45 years old, maybe 46, I don't know. I don't even say that old. So, I mean, I was born with the bare metal machines, and you know, you can tune everything. You can get the real performance out of the box, etc. So I still say, please, if you have like some kind of bare metal machine or maybe virtual machine, but just make sure that if you have in a separate disk, that would be great. Why? Actually, this talk is going to tell you why. Why we should keep it in a separate drive. Okay? So this is a built-in feature. So there is not, you cannot turn off WAL. All the write operations are WAL logged. So you cannot turn it off. But of course, I'm going to show you a single way not to turn off WAL, but disable WAL logging for a single table or multiple tables. I'm sure you know that one. Anyway, so years and years ago, life before WAL, all the changes, of course, used to go to the durable storage for a good reason. Data pages are loaded to the shared buffers. Changes are made there. So when you're running a transaction, even still the case, this transaction is executed in the shared buffers, and then eventually we will have dirty buffers. So in Postgres world, actually it's the same with the operating system. Like if you have dirty buffers, means they are not synced yet to the data files from memory. The same thing applies in here. So we have dirty buffers, but not this is not timely written. So there is not a first in first out operation in Postgres. Okay? They are not time written. Actually, that's why we have WAL files. Otherwise, we would just skip WAL files and directly update the data files, which will kill the performance for a good reason. So before WAL, if there was a crash, we would lose the data. But that was 25 years ago. Probably even more. I think that was 26 or something. So, I mean, that was a long time ago, but this is what we had. So, almost all of the modifications are logged to the WAL files. So, what could be a modification? Tell me. Sorry. Just tell me what the modification. What could be a modification from database point of view? Insert. Update, delete, what else? Create a table, right? Add a column, alter table, right? Drop a table, drop a column. Vacuum, right? Vacuum, you know, if you attended the talks of Peter or Chelsea, you have seen, you've probably heard, or maybe I'm sure you already know, but vacuum already changes the pages. So it means all the modifications, that's why I didn't say any SQL keywords, okay? All the changes are logged to the WAL files. Sorry? I'll get there. I'll get there. Even if the transaction is rolled back. So let's say we have a transaction, statement, blah, 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 and then even if we roll back them, it's written to the WAL files because we don't know whether it will be rolled back or committed, right? So we have to make sure that those statements are WAL logged, and of course, eventually we will have to log the rollback command as well. So even the non-committed transactions are written to the WAL files. First, there are, when you deep dive into Postgres, you are going to see a behavior like most of the databases. Postgres also tends to postpone the things or run the things in parallel. Okay, like group writes. And it's the same for the WAL buffers. So by default, I'm going to give you an example about, not the example, the parameter, but by default, 1 over 32, or basically some people say 3%, the same, but the actual is 1 over 32% of the shared buffers is reserved for WAL buffers. So it's actually written to the WAL buffers first, and those WAL buffers are written to the WAL files by a process called WAL writer. Okay? So basically this is how it goes. So there are lots of, there is a lot of stuff in Postgres which does those internal things. And of course, since we have the logging of we have all the modifications logged, we can recover from a crash. All right? And crash can occur anytime. Crash is fine. I mean, operating system can crash, hardware can crash, Postgres can crash. I'm fine in terms of that's not the end of the world because we have WAL. And then there is another thing, checkpoint, which we will get there because checkpoint also has doing some extra things which is important for us. So that's why I ask you to come to the front. So this is an output of PG WAL dump, which we will also mention in the next few slides. So I'm sure there are like 40 lines or something. So this is the amount of the data which was logged when I created a table. So when you say just create table T1 with C1 integer, a single table with a single column, this is the number of records that are written to the WAL files. That's why, remember, I ask you, if you can, put the WAL files to a separate storage, because there's more I/O in the WAL files than the data files under the regular load. Of course, if it's a read-only workload, you won't need the WAL files that much. I'm not talking about the regular or like mixed load or heavy write loads. Any questions so far? Again, so everyone, again, if you have any questions, just raise your hand and ask a question. We have enough time, hopefully. And this is the last talk anyway. So this is what's done, because when you create a table, it has to insert data to PG class. It has to create some stuff, and then create another information in the statistics tables, blah 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 blah. So there are lots of things that needs to be done just for a single table. In this example, I just create a table, a single table, and this can be run only on Postgres 13 and above. I mean, the vol parameter appeared in Postgres 13, and it requires an analyze. Okay, so we are just inserting 10,000 rows to a table. Okay, by using generate series, we are using 10,000 rows. So of course there are 10,000 vol records, and then byte is almost 600 kilobytes. Okay, almost 600 kilobytes from the vol point of view. This is the vol traffic, and the actual table size is 384 kilobytes. So as I told you, the vol overhead is much bigger than the actual data write overhead, because of the things that we have to change in the database. Okay, so this is 10,000 rows. Another example. Now we have an index on the table. Okay, the same data, about 1.2 megabytes, right, of vol traffic. And then eventually the total relation size, total relation size means the table size, and if there's index or more indexes, everything over there. So we created 1.2 megabytes of vol record, and then only 124 kilobytes, or half a size of the actual table. So hopefully this shows you the overhead of the vol file or the vol record. Okay. But we need it for lots of reasons. It's not just for crash recovery. So how many people started using Postgres like before 9.0? Okay. So before 9.0, we didn't even have an in-core replication. Okay. So the main purpose of the vol files was crash recovery and some kind of hot backup, cold backup, like vol backups, nothing else. Okay, we used to back up the vol files and replay them. Starting 9.0, the first thing that we added was the hot standby feature and the in-core replication, which is streaming replication in Postgres. And at that point, we started adding extra information to the vol file. Okay, so because we have to replicate them, so the replica server or servers needs to understand the transaction so that they can replay on the standby nodes. And then in version, in 9.1 we had synchronous replication, and 9.3 cascading replication, blah blah blah. And then in version 10 we had logical replication. Now with the logical replication, we actually need to have more data in the vol files. So this is the output of the just replica one. So if we have there is a parameter called vol level, which I'm going to talk about towards the end of the talk. The overhead is much heavier. So again, these are the things that we should know. Then these are the things that we cannot avoid. If we are using logical replication, we have to change the vol level to logical. When we restart the database, it means we are going to have more vol overhead. Okay, so these are the facts. And And then now I just inserted two records. Okay, insert into same table, fresh table. Okay, I recreate the table, and just two records. And then, yes, there are two records and 118 bytes of vol record. Just for, two columns. Each of them are 4 bytes. This is the on-disk print, but the vol overhead is 118. So just to give you some different numbers so that you can understand understand the WAL file. So again, as I told you before, we use it for transaction logging, replication, point-in-time recovery, and redo. Okay, redo is actually the crash recovery. Do it again. So during the regular times, we insert something, and when Postgres processes transaction, checkpoint and BG writer we will get there, writes the data to the drive, and eventually, as soon as the data is on the disk, we don't need to recover from the data from the WAL files, right? Because if the data hits the durable storage, means data files, we don't need to recover them anymore, okay? So we will get there. So this means redo means replaying the transactions, means recovering after crash. In order to have a full redo, we have to have all the WAL files. So if someone removes the WAL files accidentally, you have to restore them from backups. Or if there's disk failure, which actually makes one of the WAL files inaccessible, we cannot process the redo after that point. So we can only recover with the sequential available WAL files, nothing more. And of course, there is no redo for temp files, and as you said, we will get there of the unlock files. Oh yeah, so this is the unlock file, the unlock table, sorry. So if we create another table, which is unlocked table, means it's not going to be logged to the WAL file. As you can remember, as you can see, there is no WAL information in here now. In the previous slides, with the regular table, we had the WAL record information. Okay? But if we have the unlocked table, then it's not logged to the table. So let me compare the runtimes. The same table, let me compare with this one. The same table, 45 seconds versus milliseconds versus 30 milliseconds. Well, it's not that bad, but this is how it goes. Okay. So if with the unlock table, you can skip WAL logging, but then it means, per what I told you, we cannot replicate, right? Or we cannot recover in case of a crash. But if you do a graceful shutdown and a restart, even a server restart, no problem. It won't be deleted. Data will be still there. But in case of a crash, we will not be able to recover the unlock tables. So of course there is a use case for unlock tables. Like that's just to create a summary table, right? So if you want to create a summary table as soon as possible, just use an unlock table, create it, and run your query. Because if something goes wrong, you can recreate the table without any problems. You won't lose the data, you will just lose some time, that's all. But eventually, you will get rid of the WAL overhead. As I told you, shared buffers is the place in Postgres where we perform the transactions, and there's dirty buffers. And there's inconsistency. What does inconsistency mean, and why this is an important information? One of the mistakes that I have seen on the field about taking backups of a running Postgres database is taking a snapshot of the disk. Unless you shut down the database, taking a backup of a table, taking a snapshot of a disk will end up with an inconsistent data. The reason is background writer. Background writer is also called lazy writer in the source code. It uses a least recently used algorithm to clean up the dirty buffers from the shared buffers and just to the kernel cache or maybe out of the cache or maybe swept or just to the disk. I don't know. Depends on the kernel. So eventually, let's say we committed a few transactions and they are on all the shared buffers now, which are not committed, which are not synchronized which have not been synchronized to the WAL file, to the data files yet. Okay, so we ran a few transactions. They are written to the WAL files, but not yet written to the data files. So BGWriter starts. BGWriter runs often, even by the default and like the bad values. It runs in every 200 milliseconds, which is not enough. It's not enough for production. You should decrease the value, but there's not a topic for this talk. So it picks up the least recently used one to synchronize the data to the disk. Means not the first in, first out. So eventually, overall, Postgres knows where the data is. So when you query the data, it won't be a problem because it's either in the shared buffers or in the disk, right? But if you take a snapshot of the running Postgres database, the data files is inconsistent. Okay, eventually you may not be able to recover from because of that reason, which is fine, and then because then we have checkpointer. Okay, checkpointer just flushes everything. Means at the end of the checkpoint, the data files reach to a consistent stage as of the checkpoint end time. That's why Postgres runs checkpoint when you shut down the database. That's why Postgres runs a checkpoint after a crash recovery. That's why Postgres runs a checkpoint before drop database. Because we have to make sure that everything is written first to do the operation, to the next operation, okay? So checkpoint is responsible for everything. And also, there is another thing which is a problem in most of the cases. The query backends may also write the data to the heap. I mean, to data files, okay? Then that's another problem. So eventually, there is inconsistency, okay? So when you go to a Postgres conference, or when you're speaking with some Postgres people, or when you're doing a job interview, if you want to look sexy, use this word. Hey, I know what log sequence number means. I have seen log sequence numbers. LSNs are great, okay? I had a dinner with LSN. She was great. I had a dinner with LSN. He was great, okay? So stuff like this. Seriously speaking, LSN is one of the sexiest keywords in Postgres. It shows you, it tells you the position of the record in the WAL file. So remember, we inserted something, a few things, and each insertion creates a WAL record. And each of them has a unique number. It's called log sequence number, say LSN. Okay? It's 64-bit integer, but actually 2 times 32 bytes. I'll get there. I'll get there. Bits. I'm sorry, bits. And it's a pointer to a location in the WAL file. And LSN is called the block ID and the segment ID. So what does it mean? What's block ID? What's segment ID? We'll get there in the next slide, okay? So during the recovery, let's say Postgres crashed or operating system crashed, okay? Hardware crashed, whatever. We are restarting the database. LSN on the page, LSN on the data page, and LSN on the WAL file are compared. The larger one wins. Means if LSN on the page is greater than the value on the WAL file, it means that has already been written to the data files. But if LSN on the data file is less than the value on the WAL file, means that WAL record has not been written. I mean, checkpointer or BGWriter couldn't complete the couldn't complete the right operation yet, which is fine. Okay, doing normal operation, that's 100% fine. Doing normal operations is 100% fine. So the larger one wins. That's how Postgres recovers. So let's talk about those 6 things. So if you have seen the Postgres WAL files, this is the naming. This has been, I mean, as I told you, I'm old enough to talk about Postgres, and it was 16 digits when I started using Postgres. In Postgres, I think 8.0, we added the timeline concept, and that's the timeline ID. So the first 8 cards is the timeline ID, and 0001 is the timeline ID created by initDB process. This is the first timeline. So it means when you say, let's say, failover, failback, okay? These timeline IDs are going to increase one by one after each regular operation. That's again okay. We are just keeping the timeline IDs. So actually, this is useful if you want to go back to a specific timeline in the past. Okay. So the second one is the block ID. Remember. So let's go back to the previous slide. Remember, LSN is the block ID plus segment ID. We'll get there again. So this is the block ID. This is the segment ID. This is the first. So in every Postgres installation, when you initialize the database cluster and start up the cluster, this is the first WAL file name. And it's always 16 megabyte by default. On disk size, it's always 16 megabyte. 16. Why? I mean, not why 16. 16 is, as I told you, 16 has been decided already. But why it is always 16 megabyte? The reason is, one of the most expensive operations in the file systems is extending a file. Because when you extend a file, it has to find a new space. Sorry, it has to find a new space on the disk, and tell the file allocation table this is the next few bytes of the continuous of the previous file. So extending a file is extremely expensive, right? And as you have seen before in the first few slides, WAL is already an expensive thing. So instead of extending the file, we reserve a disk space and then fill it up. That's the reason why it is always 16 megabytes. Or whatever the WAL size is, but it's always whatever the WAL size is. Okay. So the next one would be 02, and again this hexadecimal. So when it reaches FF, block ID is increased by 1, and this goes to 0. So the last 2 digits are only used. This is for a good historical reason, and to be honest, I learned the reason about 5 years ago. I mean, when I first started working on this talk, in the first version of this talk, well, I mean, what's the reason that it's here? It's because, I mean, again, let's show it in here. When it reaches FF again, it's 0.02. The reason is actually it's written in the code. It's just because of this and that. This is the reason. This is the full technical reason that why we use that one, and to see this number of the F's displayed in the previous slide. That's the calculation and the reason why the names are like this. Okay. And to be honest, I found this information. I asked the information from a hacker, which, as far as I know, it's not available in documentation. So that's why I keep the long slide just to talk about this one. Which is the current WAL file? Which is the current WAL file that I'm using? So if we select start from PG current WAL LSN, it gives you the LSN. So this is the, let's go back here. This is the block ID, the blue one, and the red one is the segment ID. Let's go. Blue one, and this is the record in the segment ID. Okay? So this is so if 40E6 is here, 40E6. Okay? So it gives you the block ID of the WAL file. And then if you give the output to the PG WAL file name parameter, it's going to give you the actual WAL file which is currently being used. Or just make it shorter, use the two functions that's like combine two functions. So static PG WAL file name, PG current WAL LSN, then it's this. Okay? Any questions? Okay. So as soon as now let's talk about checkpoints. As soon as the checkpoint starts, a redo point. We talked about redo. It's stored in the shared buffers, and then a WAL record is created because we are starting a checkpoint. Okay. I'm going to show you a few of them later on in the final section of the slides, and it's eventually written a file called PG control, and we will talk about also PG control. PG control is under the data directory and global directory and under the data directory. Okay, there's a one single file. So if you are familiar with Oracle, it's a control file again, but there's something different from Oracle. I'll get there. And as we discussed before, unlike BG writer, checkpointer writes all the data in the share, all the dirty data, not all the data, sorry, all the data from the shared buffers to the durable storage. And then this is the output of PG control data before version 11. I know the 11 is the minimum supported version nowadays. So, but since I would like to show you the previous version. So in the past, we used to keep two checkpoint locations. So we used to keep 2 checkpoints worth of WAL files under the PG WAL directory. Starting version 11, we keep only one of them. This is one of the things that Simon committed, and they are log sequence numbers. And when the checkpoint is completed, we update PG control again. And after the checkpoint, the old WAL files are often recycled or maybe removed. So remember the expensive operation in the file systems. Extending a file is already an expensive process, and we got rid of that overhead by creating the file ahead of everything. So, and another good news, we don't delete and recreate them. We just recycle them. Just put rename them, put it towards the end of the queue, and use them. So once we create a few blah blah numbers or amount of WAL files, we are fine, we are safe. Okay, we recycle. Of course, based on the traffic, checkpointer may decide to add more WAL files if it thinks that we need more files to be able to handle the load. And at some point, if it thinks, well, we don't need them anymore, it may remove them. Okay? So the regular operation is just recycling, but in some cases you may see just edit or removed if you enable log checkpoints parameter in PostgreSQL file. So in every startup, regardless of whatever, every startup, okay, Postgres always reads the PG control file. So if you run this command, like PG control data binary against the data directory, and if you grep the state, you will see one of them. So it could be starting up, means database is starting up right now. Shutdown fine, gracefully, no problem. Shutdown in recovery, it was shut down during the data recovery mode. Shutting down, it's like starting up, currently it's shutting down. It's in crash recovery, means we are recovering after a crash. In archive recovery means we are getting fed by the archives, or in production means database is up and running, right? So if PG control says it's in production, but database server is not running, means this instance is eligible for recovery. Means something wasn't properly shut down. Again, if it says in production, but if the database is not running, means something crashed. Okay, so in every startup, Postgres every startup Postgres checks this. So let's talk about PG control. Thank you. Let's talk about PG control. PG control, as I told you, is not like Oracle's control file, but unlike Oracle, we don't multiplex that one. So we have one single file. In theory, in documentation, it says it's a weak spot of Postgres, but we have never heard from anyone on the field, from the field at least, we didn't hear, and I didn't see any, about the corruption of PG control file. Okay, so we don't. I mean, it's doable. I mean, it's doable means there's a way to recover by checking the WAL files and blah blah something, but no one implemented this one yet. Okay. Let's talk about the PG WAL dump binary. We are all human. I'm sure everyone in this room, or maybe not everyone, but try to open a binary file with a text editor, right? We try to open a binary file, and lots of warnings come over there. So that's okay, but for such people, we have PG WAL dump. And we have another thing as of Postgres 15. If you want to see the contents of the WAL file, not the full content, but what it does, you can use PG WAL dump. Okay, like if you are familiar with the tail command in Linux, it's the same for F for follow, and M for limit, and Z for the stats. So PG dump blah blah. So it gives you the 20 last 29s and follow, and you give the WAL file name, the full path to the WAL file. So it gives you the resource manager. In this case, it's heap resource manager, or this could be transaction resource manager. It could be the WAL resource manager. Like at this point, it start the checkpoint. Okay, and then insert, commit, hot update, commit. This is what's done, and eventually see this switch. Means it switched to the new WAL file because that file is either filled up or maybe let me show it in here. Archive timeout was reached, or DBA forced a WAL switch by PG switch WAL command, or it could be a standby. Replica information. Remember, I told you replication also added some extra overhead. So these are the extra information written for the standby. So there is something called FPW in here, which is one of the most important topics in this talk. Okay, we will get there. But eventually, at this point, we have seen a couple of it, in this case, FPWs. So what's FPW? We will get there. About PG WAL dump, if let's say this is actually Postgres restart. So when you restart, it runs a checkpoint, as I told you, and it gives you the information about the parameter changes, which require restart. The reason is those parameter changes could be important for the standby node as well. That's why we urge the Postgres users to make those changes on the standby node first, so the standbys will be aware of the upcoming changes. Otherwise, lots of things may fail. For example, if you change shared buffers on primary first, and if you restart Postgres database, standby will fail. Probably will fail. Often will fail. Okay. And as of Postgres 15, we have PG WAL inspect. Unlike PG WAL dump, this is a SQL interface. So it's an extension. PG WAL dump is a binary. This is a SQL extension. Okay. So it's available by almost default. It's in the contrib modules. So if you are using the RPMs, just install the contrib RPM. You should already install those packages because of PG statements anyway. So create extension PG WAL inspect. So if you give an invalid LSN number, this is LSN again, it says requested WAL segment has already been removed because it's not there. If you give something in here, cannot accept the future input LSN, which the file is there, but it's not we haven't reached that point. Or if you get an actual stuff, it gives you the information about the WAL file, about the LSN record. Okay. Yeah, I got 5 minutes, so I need to skip a few things. Let's talk about full page writes. Okay, full page write is extremely important because one of the problems again in the computer industry is partial writes, right? Partial writes of the pages. So let's say something is being written to the physical storage and crash or power failure or something happened. Okay, so this is a partial write. So it's neither the previous version nor the new version. Okay, to recover from those situations in the WAL files, we have full pages of each page, each 8 kilobyte of page, which changes after each checkpoint. So if there is a checkpoint, and after the checkpoint, if the page changes, even a byte, the full page is written to the WAL files. Okay, this is called full page write. It helps you to recover the page in case of a partial write issue. Okay, so eventually you can don't do this in production, but if you unplug a Postgres machine, and you will be able to recover all the committed data. I mean, don't do this on production, don't test on production, but you get the idea. If you commit everything, and we answered this question in 2005 to Tom Lane. The question was, how much do you trust Postgres? His answer was, I trust Postgres as much as you trust kernel and the hard drive. As long as means we rely on the hardware that much. So if we can write everything to the WAL files or the data files, then we won't lose the data. That's why the logo is elephant. Elephant never forgets. Okay, that's the reason that we claim so. Of course, it increases WAL I/O because we are adding like extra load on the WAL files. It's also called full page image (FPI). So as of Postgres 13, in analyze output, I think you can see the keyword FPI, which is called full page image. Okay. So the thing is, the important information in here is Postgres writes the header data and the entire data page is a WAL record when a page changes after every checkpoint. So increasing checkpoint timeout or max WAL size may help. Of course, when you increase those values, it means in case of a crash, the recovery times will be higher, maybe higher. So this is a trade-off, but the lower checkpoint timeout values may end up with lots of WAL traffic if you are running a heavy write system, or heavy write system. Okay, so you should just make some tests and find the optimal value for this. Okay. So yeah, I mean, let's talk about, is the final few things. WAL compression. WAL compression is also important for full page writes. Actually, this doesn't compress WAL files. This is slightly misleading parameter. Actually, it compresses the full page images written in the WAL files. Okay. So it doesn't compress the full WAL records, but it compresses the full page images with one single minute. I'm just summing it up. So it could be off on PGLS, LS4, and ZSDT starting Postgres 15. By default, it's off. If you turn it on, it's PGLS. It's less compression, but fine. But if you want to compress more, you can set it to ZSTD, but it's going to use CPU more. Okay. Again, trade-off. Trade-off. So, yes, please. Sure.
That can help making replication faster?
No, because those files will be decompressed when needed, and then we will need. So eventually they will be the same. It's, Maybe replication traffic faster, but not replication faster. Any questions? Okay, usually I take a pictures and put on Cheers Postgres, but this time I won't take the picture. Like it's the end of the night, end of today, we're all tired. So thanks for joining me. Again, you can find this presentation on Scale website. I think so. You should be able to find it. But there is an older version available as a recording in Postgres London website. So if you Google the title, you will find the previous version. I mean, it's more or less the same. It's just been updated for Postgres 15. You can still find the video. You can download slides from somewhere else, but not sure. It's my first time in Scale. Sorry, I don't. So
Eventually, I've uploaded slides to the website.
yeah. So we'll eventually be able to find slides there. Thanks for coming, and hope to see you next year.